So this is Unit 910, looking for relationships, and we're working in box H here, finite differences. What we want to be able to do by the end of this lesson is to use the finite differences to determine a relationship, to determine if a relationship is linear or nonlinear. So what do we mean by finite differences? Well, we use finite differences when what we are given is a table of values for a relationship. So here we can see our table of values. We've got x and we've got y, and we've got the x coordinates and the y coordinates listed underneath the appropriate headings. To calculate the finite differences, we want to work with our y values. Okay, so we're looking at the numbers in this y column right here. And what we do, the easiest thing to do is to start at the bottom of our table. So I'm going to start down here with 12, and we're going to take one of our y values and we're going to subtract the y value that is above it. So I'm going to look at these two y values. I'm going to start at the bottom, and I'm going to do 12 minus 9, okay, subtracting the y value above it, and I get 3 when I do that. The next row in my table, I'm going to do the same thing. I'm going to take my 9, and I'm going to subtract the y value above it. 9 minus 6 equals 3. And I'm going to work my way up the table. Next up, I've got a 6, so I'm going to subtract the one above it. 6 minus 3 equals 3. Next up, I've got 3. 3 minus 0 gives me 3. And I can't really do anything for that top row because I don't have a y value up above, so I can just put in a line there to show that I can't calculate a finite difference. Now, what do we notice about our finite differences? Well, our finite differences are these numbers right here, okay, the 3's. These values represent the differences between our y values. And we notice that all of these values for our finite differences, 4 of them, are the same. What does this tell us about our relationship? Well, over here on the right-hand side, we've got a graph of this relationship. We're plotting x and y here, and we've put the points in here with these little dots. So each of these coordinates from the table is plotted over here. Now, what kind of a relationship do we see in this table? Well, we see a linear relationship. You can draw the line of best fit right like that, and it goes through all of our points. Okay? So we can sort of sum this up by saying for a linear relationship, the finite differences are the same. Okay, our finite differences were 3 in each case. And all this means is that for each x value that we go over, we're going to go up by the same amount each time. All right, so it gives us the straight line. There's one sort of thing we have to note. As long as, notice what's happening in our x values over here in our table. As we go down each row in our table, our x value is increasing by 1 each and every time. Okay? Each time x is going up by 1. As long as our x variable is changing by the same amount in each row. So, let's see, as long as x changes by the same amount in each row. So let's just read that whole statement again. For a linear relationship, the finite differences are the same as long as x changes by the same amount each row. So if instead of changing by 1 every time, x changed by 1 the first time, then by 3, then by 7, then by 10, our finite differences wouldn't work to tell us whether this relationship was linear or nonlinear. So what do you need to be able to do? Well, here's the kind of question you need to be able to answer. If you're given a table, x and y, you need to be able to find the finite differences and be able to conclude whether the relationship is linear or nonlinear. So let's do our first table here. Okay. First thing we should check is to see whether x in fact goes up by the same amount each time. So I look at this, yeah, x is going up by 2, 2, 2, 2. So our finite differences are going to work here. So now we calculate our finite differences. Again, we're looking at the y values. We start down here at the bottom, and we subtract the one above it. So 3 minus 1 gives us 2, and then we move up in the table. 1 minus negative 1, it's like 1 plus 1, gives us 2. Negative 1 minus negative 3 gives us, well, negative 1 plus 3 gives us 2. Negative 3 minus negative 5, and just subtracting the one above it, again, gives us 2, and we can't really do anything in the top one there. Okay, we look at our finite differences. They are 2, 2, 2, and 2. What does this tell us? Well, if first differences, finite differences are all the same, so our relationship must be linear. Let's take a look at our second example here. Again, we've got a table. We can double check that our x values go up by the same amount every time. Yep, 1, 1, 1, and 1. Okay, so let's do our finite differences. We will start down here. Remember, we're looking in the y column. Start at the bottom with 4, subtract the 1 above it. 4 minus 9 is negative 5. Then we move up. 9 minus the 1 above it is 9 minus 15. That is negative 6. They're different already, but we should calculate all of them just to make sure here. Maybe we just made a calculation mistake. Let's see, 15 minus 22, negative 7. 22 minus 29 is negative 7. Okay, so my finite differences here are negative 5, negative 6, negative 7, negative 7. They are not all the same, so this relationship is non-linear. And that's all you really need to do at this point with finite differences.